done to the denominator and use calculator, you can figure out. Next, find accumulated amount after 4 years. If $5,000 is invested at 5% per year, compounded continuously. Now, compounded continuously. Let's talk about the compounded continuously. It's this table here. This is a amount, compounded interest rate amount. Here n, we have m equal 1 equal 2 semi-annually, 4 quarterly, m equal 12 monthly, m equal 360 daily. If you keep going on, make n terms become infinite, very, very large. Then this we call compounded continuously. Continuously. If n go infinite, become compounded continuously. So amount equal principal 1 plus r over n to the power mt. When compounded continuously is this approach to what? As n approach to infinite. Become compounded continuously. Now, we are going to do is this one. This part. This part. And we let this part, we are going to let 1 plus r over n to the power n approach to a number, that number e to the power e to the power r. R is interest rate. As m go infinite. So we can write as limit. Limit m go infinite, 1 plus r to the power n equals e to the power r. So what is e? We have talked about, we learned e, natural number, before. We didn't define what is e. So here's the definition of e. What is e? E is a number such that when m approach to infinite, this number approach to e to the power n, e to the power r, which is right in limit. Is limit m approach to infinite, 1 plus r over m to the power n equal a number we define is e to the power r, e to the power r, this r. Now you let r equal 1. If you let r equal 1, you got limit n approach to infinite, 1 plus r is 1, substitute in 1 over n equals r is 1. So e to the power 1, it's e to the power 1. That's the e definition. So then you can use calculator. M equal 1, you got 2. M equal 2, you got 1.5 squared. M equals 3, you got 1.1 add 1/3 to the power 3. If m equal 4, you got 1.25 to the power 4. M equal 5, you got 1.2 to the power 5. Keep going on until infinite. And that number will be approach a number. And that number is this. Is 2.7. The actual one is what? Let's see. Actual one is and you use calculator. They use calculator. Figure out is 2.7. 1, A2, A1, A2, keep going on. Keep going on. This is, and then this number is hard to represent. We just represent by this symbol E. So that's E come from. How we figure out that E is this one. You use calculator m go from 1, 2, 3, 4 until very, very, very big. And that number is going to be approached to 2.718281828. Approach a number like this. And this number is hard to represent. So you just write a symbol E. This is the E come from. This is the E. And we call this number defined as a natural number. Natural number. So if compounded continuously, if we go back to over here, so we figure out this is e to the power r. Over here, e to the power r. If m go infinite, we call so when as m go infinite, this is approach to p. This is e to the power r. E to the power this r. As m approach to infinite, this p, this part is approach e to the power r to the power t, and that's p e to the power rt. And this is amount. This is a compounded continuous formula. Compounded continuous formula. M is very, very big. That's compounded continuously. Every single little moment will earn interest, so continuously. This is a formula for compounded continuously. So therefore, here the question we have, we did over here, here, this one, number 16, compounded continuously. Find after 4 years, if 5,000 is principal, invested at 5%, R is 0.05, compounded continuously. So use this formula. A equal P times e to the power RT, compounded continuous formula. P is 5,000, e to the power R is 0.05, interest rate. T is 4 years, plug it in. So got 5,000 e to the power 0.2. Then use calculator, you get this. Next one, how much money should Jack deposit, which is in the beginning, how much money? So figure out the P. In a bank, paying interest rate at rate 6% year, compounded continuously. So use same formula, use this formula again. P is we are looking for, R is 0.06. At the end of 3 years, so T equals 3, plug in. The accumulated amount will be $20,000, so A equals $20,000, and looking for P. So this one, you divided both sides by this, so this cancel and then go denominator, become 20,000 over e to the power, tying together is 0.18. So use calculator, divided, you got the, in the beginning, the principal, how much dollars. Next one. Find the interest rate needed for an investment of $5,000 to grow to an amount is $7,500 in 3 years. If interest is compounded quarterly. So this is looking for R, interest rate. So amount become $7,500. That's A, put it in A, equal original $5,000 investment. $5,000, so principal P is 5,000. Parenthesis 1 plus, we are looking for R, compounded quarterly. M equal 4 to the power M times T. M is 4. T is 3 years, is 3. So looking for R. So first of all, we are looking for R, so we need to isolate this term. Then we can get R. How to isolate this term? So we have to remove this to the left side. So divided by 5,000, both sides cancel and get 1.5 equals, this cancel equals 1 plus R over 4 to the power 4 times 3 is 12. Then you will do here, this one, 1.5 equals 1 plus r over 4 to the power 12. This one, go next step. We are going to isolate this term. So how to isolate this term? So we have to get rid of this 12. How to remove that 12? You do to the power 1 over 12. This also to the power 1/12. Both sides to the power 1/12. And this time together equal 1. So you got 1.5 to the power 1/12 equals 1 plus r over 4. This time together equal 1. This. Then you minus 1 both sides. And so you got r over 4 equals 1.5 to the power 1 over 12 minus 1. Then you times 4 both sides. And you got r. So we are going to 1.5 take to the power 1 over 12. Right side, this one also take to the power 1/12. And the two times together equal 1. So you get rid of 12. So you got 1.5 to the power 1/12 equal this time together power rule equal 1. So you get 1 plus r over 4. Then r over 4, move 1 over, change the sign, become this minus 1. And then both sides times by 4. Times by 4, both sides. And use calculator and figure out 1.5 to the power 1 over 12. Then subtract 1 and then times by 4. And you will get this one. And then you move decimal. Normally 2 decimal digits. 2 decimal digits. You got 13.75%. Because you move this over here and you rounding. Normally 2 decimal digits. Yeah, 13.75%. If you want more digits, it's fine. And usually 2 decimal digits or 4 decimal digits, it's fine. If you want more, fine. If you don't, make sure just write down all the numbers from calculator. And like this, all the numbers from calculator. And then, because the interest rate, normally we write as a percent, you have to change to percentage. 19. How long this 18 looking for interest rate. 19 looking for T. So how long will it take? $5,000 and to grow to $65,100. So principal is $5,000 and $6,500 for a month. And times 1 plus. Interest rate is 6%, 0.06 over compounded monthly. So M term, 12 months to the power M times T, 12 times T. And looking for T, solve for T. So first of all, we have to looking for T. So first of all, we can divide it by 5,000 both sides, get 1.3. And this cancel equal. This 0.06 divided by 12 is 0.005. Add 1 is 1.005 to the power 12t. Get this. And solve for t. Solve for t, we take ln both sides. So this ln 1.3 equal this side ln this. Use power rule. This 12t go from power rule. Power rule is log x basis b x to the power n. This n go from n log b x power rule. This. So this 12t is n go from 12t. Then ln 1.005. Isolate the t. Isolate the t. You divide it by 12 done. And divided by 12 both sides. Divided by both sides by ln 1.005. So which is this 12 and this one. Move down to this side denominator, divided, and use calculator. And figure out is 4.3837 years. If you want to go to decimal digits, like 4.39 years, it's fine. It's fine. Usually 2 decimal digits or 4 decimal digits. Number 1, number 2, page 3. And before this question, before we learn is we learn is exponent and the logarithm, exponential function and the logarithm function, and use in the compound interest or continuous interest. That's we learned. Now next we are going to learn derivative of exponential function and logarithm function. Derivative. So derivative of exponential function is this. If e to the power x, you take derivative. Prime, or we call derivative, is still e to the power x. If e to the power u is in terms of x, we take derivative. First of all, e to the power this, take derivative is still e, still itself. E take derivative is still e. And by the chain rule times by this function in terms of x, u prime of x. So normally we put this e to the power u. If you take derivative, is still e to the power u times u prime. This formula. That's e. E to the power x is still e to the power x. And why? You can use definition of first derivative to prove. Remember, definition of first derivative is limit h approach to 0, h f of x plus h minus f of x. That is f prime of x definition. Is the slope of tangent line. Slope of tangent line formula. This is slope of tangent line. It's f first derivative. And use this, you can prove e to the power x, take derivative, f prime of x is going to be still itself, e to the power x. I do not spend time to prove it. And for this one, then use chain rule. E take derivative. E function take derivative is still itself. By chain rule, this one is in terms of x and take derivative u prime of x. And normally we put eu prime equal eu times u prime by chain rule. So like this one, exponential function take derivative. E to the power 3x take derivative is still e to the power 3x. Then by the chain rule is two functions if a composite, if a function f composite function g. This two function composite take derivative is outer function take derivative times the inner function take derivative. That's chain rule. So this outer function is e function take derivative is still e to the power 3x. And the inner function is 3x take derivative. 3x take derivative is 3 times 3. And normally we put number in front of the function in the front. So here show you formula. And then this one also the e function take derivative is still e, so still e to the power negative x. By the chain rule, negative x take derivative is a negative 1. Negative 1 we don't write out. And this one we use the product rule. Remember the product rule. Here the product rule is f product g times g take derivative is f prime times g add f times g prime. That's a product rule. So this is two function product. So product rule. First function is f, second function is g. F prime product rule. After take derivative is going to be first function x cubed. Take derivative is a 3x squared. 3 go from 3 minus 1, 3x squared. Times the second g. Second function do not take derivative times e to the power x plus f times g prime. F function, first function do not take derivative x cubed times Second function, e to the power x, take derivative is e to the power x. And you can leave answer like this, no problem. Or you can go common factor out, x squared, x cubed, pick up the lowest exponent, x squared, common factor, e to the power x, factor out. And so this x squared, e to the power x factor out remains 3. Put it in the parentheses, plus x cubed, take out x squared. X cubed divided by x squared remain x. E to the power x divided by e to the power x cancel. So this one factor remains 3. This one factor x squared remain x. Next one, use quotient rule. Remember quotient rule. It's f over g prime equal g squared, denominator square, f prime times g minus f times g prime. That's quotient rule. So this take derivative, denominator square, g squared, denominator square, get x squared. Numerator take derivative, e to the power x take derivative is still e to the power x. F prime times g. G do not take derivative, so times x. Here's minus f times g prime. F is e to the power x, g prime, g denominator. X take derivative equal 1. You can leave answer like this. Or you can factor out the common factor, e to the power x. E to the power x factor out remain x minus 1 in the parentheses. So this one we learned the e function take derivative is still e if by the chain rule times u prime. And then the natural logarithm function take derivative. Now natural logarithm is ln x. This function, if you take derivative, it's 1 over x. And you will ask, why is this? And we can use the definition of first derivative we learned in the chapter 2 to do, which is limit h approach to 0, f of x plus h minus f of x over h. And you will get is 1 over x. And then, so, and put it in general, if ln u of x take derivative. First of all, according to this, is 1 over u, and times by the chain rule inside take derivative, u prime. So it's going to be this one. So like first one, ln take derivative is 1 over x. And this one, ln take derivative is 1 over this. This is u, 1 over 3x times u prime. This 3x take derivative is 3 times 3, and cancel 3, got 1 over x. For this one, ln take derivative is 1, ln x take derivative is 1 over x, is 1 over 3x squared, this one. And this one take derivative times 1 over u, and times u prime. U prime is 3 times 2, 6. 2 minus 1, so 6x. And 6 divided by 3, get 2. X squared and the x, cancel x, get x on denominator. 2x, 2 over x. This one also. ln take derivative is 1 over this u. So it's 1 over this, still this. By the chain rule, this u need to take derivative. This one take derivative. E to the power x squared take derivative is still e to the power x squared. By the chain rule, x squared take derivative times 2x plus 1 take derivative is 0. And then you multiply, get 2x e to the power x squared over this, over denominator. For this one, use quotient rule. Quotient rule, it's F over G prime is equal G squared, and F prime times G minus F times G prime, this one, this formula. So first of all, denominator square, x plus 1 quantity square. Numerator take derivative, ln x take this 1 over x times denominator do not take derivative times x plus 1 minus numerator do not take derivative ln x times denominator x plus 1 take derivative is 1. Because x to the power 1 take derivative is 1. 1 take derivative is 0, is this. So then you do simplify it. Since here has a denominator is x, so each term times by x. This times x cancel, get x plus 1. This times x, get x times ln x. This also times x, and you got this one. And this one also 1 over this u, so get 1 over this u, and then this u take derivative. This one is similar to this one. Then e to the power 4x take derivative is still e to the power 4x. By the chain rule, 4x take derivative is 4 times by 4. Add the 3 take derivative is 0. So we got this. This one and this f and the g actually are similar. So ln take derivative is 1 over this u, 1 over this, and u prime times u prime. This take derivative. E to the power 5 take derivative is e to the power 5x. By the chain rule, 5x take derivative is times by 5. Plus 2 take derivative is 0. So we got this. Then h, also quotient rule. Denominator square. Denominator 1 plus e to the power x squared. By the quotient rule, it's f prime times g. Numerator f prime ln x take derivative is 1 over x times denominator 1 plus e to the power x. Then here minus numerator ln x times denominator take derivative 1 take derivative is 0 plus e to the power x take derivative is e to the power x. And they all have, here has a denominator x, so both sides times x. So distributed in first term times x, x cancel, remain this 1 plus e to the power x minus this term times x, x times e to the power ln x, and then denominator times x. I got this. And the following, Jane has narrowed her investment options down to two. Two options. A option, purchase a CD that matures in 12 years and pays interest upon maturity at a rate 5% per year compounded monthly. Those are application section 5.3 compounded interest application form problem. So use this compounded interest formula. A equals, here doesn't give you principal how much, so you assume it's P, times 1 plus interest rate 5%, 0.05 over compounded monthly, 1 year, have 12 months. So M equals 12 to the power 12 times 12 years, 12 months times 12 years. So total in 12 years have 144 months. And 0.05 times 12 is like monthly interest rate, and to the power how many total, how many months in 12 years. So then you figure out this one, use calculator. And P we don't know, so we leave answer with P. You got 1 point and rounded is about 1.82 P times principal. So this is amount. And compare with the option B. The option B is purchase a 0 coupon CD, and that will double her investment in the same period. So in the same period, that's in 12 months. Same period means after 12 months, the coupon CD will be doubled. Original invested P dollars, double, become after 12 years, become double, become 2p. And compare the two, which option will optimize James' investment. That optimize means which one is it's a better investment and get better amount. So you compare A. After 12 years, amount is 1.82p. Compare with this. Second option is double as principal, is amount after 12 years, 2p. So 1.82p. 1.82p is less than 2 times p. P is the principal. If principal is $1,000, then you got $1,820 is less than $2,000. So look like this 2 is larger. That's better. So answer is option is B. Question 23. Moshe has an individual retirement income. Individual IRA. Individual retirement account IRA with a brokerage firm. Her money is invested in a money market mutual fund that pays interest on a daily basis. On a daily basis. 1 year has 365 days. Over 2 years period, T equal 2, in which no deposit or withdrawals were made. Her account grew from $4,500 principal become amount $4,792.61. Find if our effect rate at which Moshe's account was earning interest over that period. 1 year. Effect rate is 1 year interest rate. So first of all, you have to figure out the original interest rate, annual interest rate. Figure out R first. How to figure out R? Use compound interest amount formula. Principal, P use $4,500, plug in P, equal amount use 4,792.61, plug in, times 1 plus interest rate, that's we are looking for, normal interest rate, over compounded daily, 365 days to the power 365 times by in 2 years, times by 2, and figure out R. So first of all, we have to isolate this term. So we divide it by 4500 both sides, and then that means this go down to the denominator and only remain this term. 365 times 2 is 730. And we are going to isolate term, so we have to remove this. So both sides times by to the power 1 over 330. This side also to the power 1 over 730. And then 730 times 1 over 330 times together equal 1. So right side become 1 plus r to the power 365. Right side is this one to the power 1 over 730. Then you subtract 1. This move over, subtract 1. And get this. And times by 365. So you got R equals 365 times by this. And use calculator. You figure out interest rate is 0.0315, 3.15%. So this put the percentage is 3.15%. That's the nominal interest rate, 1 year interest rate. Now convert to APY, annual percentage yield. Use this effective rate formula equal 1 plus this 0.0315 over n. N is 365 compounded daily to the power n 365 minus 1. Effective rate formula is this. 1 plus R is 0.0315 over n is 365 to the power n is 365 minus 1. And use calculator. Figure out it's 0.0320. Change to percent is move decimal point to the right 2 position is 3.20%. So annual percentage yield, APY, we call effective rate, is higher than 3.15%, is 3.20%. Then next one, find the relative rate of growth. So this is logarithm function. This is section 5.5, differentiation of logarithmic functions. 24. The population of a town T months after the opening of an auto assembly plant in the surrounding area is given by this function. This function here is a negative 0.1 r. This is k. This k value is a negative. This k value is a negative. So, and what is the relative rate of growth of the population 6 months after the opening of the auto assembly plant? Relative rate. What is the relative rate? Is this one. This one is the relative rate. Is the rate P prime of t over P of t. So P of t is this one. So P prime of t is take derivative. This is the E function. If E function take derivative e to the power x, it's still this. So it's still this part. So still same as the denominator. So denominator cancel. Then by the chain rule, this part take derivative. That part take derivative. Let me write this. P of t prime over P of t is we call the relative rate, percentage rate, relative rate, percentage rate of change equals P of t is this, and since the E function e to the power negative ln9 and then e to the power negative 0.1t. And this function, if you take derivative, because it's the E function, take derivative and coefficient is constant, is still there. E function take derivative is still E, doesn't change. E to the power x. By the chain rule, then this part need to take derivative times this part take derivative. This part take derivative. Here is still negative ln9 times is still E function. So E function take derivative is still E. Still E. E to the power negative 0.1t times. Then this part, this E to the power this function, E take derivative is still E. But this one have used chain rule times negative 0.1. So it's become this one. Now let's do it again. P of t is this. Copy done. For this take f p prime. This take derivative. Constant coefficient still 18,000. Constant coefficient. E take derivative is E. Still this. Times by the chain rule. This part take derivative times chain rule. This is e to the power u prime times u prime. So this take derivative. This one take derivative. This is E function take derivative. In front is constant negative ln9 times E function take derivative still E to the power this. And this E to the power this u again, then u prime. This take derivative is times negative 0.1. So you use the chain rule twice. First of all, this E take derivative is still this E. This whole thing take derivative is still this. By the chain rule, this take derivative is going to be negative ln9 e to the power negative 0.1t is still this. And times this take derivative is negative 0.1. And this same cancel. So you will get tying together negative times negative is positive 0.1. ln9 times e to the power negative 0.1t. You got this. Now figure out what is the rate of the growth of the population in 6 months. T is how many months? T months. So 6 months. So T use 6 plug in. Here T use 6 plug in. And get 0.1 ln9 times e to the power negative 0.6. And you time together and then move decimal point to the right 2 positions and rounding. So it's 12.06%. That is the relative rate of growth of population. It's growth. That means this one is going to be positive. Next one. Section 5.6. Word problem. Exponential function as mathematical models. 25. Under ideal laboratory conditions, the number of bacteria in a culture grows in accordance with the law Q of t equal Q0 e to the power kt. If k is positive, it's grow. If k is negative, it's decay. Grow means increasing, decay means decreasing. Where Q0 denotes the number of bacteria initially present in the culture. K is a constant determined by the strain of bacteria under consideration and other factors. And the T is the elapsed time measured in hours. Now here is in hours. Suppose 10,000 bacteria. Initial Q0 is 10,000. Q0 is 10,000 are present initially in the culture. And the 60,000 present 2 hours later. So T equal 2. And the Q of T after 2 hours is 60,000. So Q of 2. T is 2. 2 hours. The Q of 2 is 60,000. So we got plug in. Q of 2 use 60,000 plug in equal Q of 0 is 10,000 e to the power k times t. T is 2 hours. Figure out the k first. A. How many bacteria will there be in the culture at the end of 4 hours? So first of all, we use given condition. In 2 hours, from 10,000 growth to the 60,000, and figure out the constant k. So plug in and divide by 10,000, and that side cancel for 0, get 6 equal e to the power 2k. Solve for k. So take ln both sides. ln 6 equals 2k go from. ln e is 1. So is ln e is 1. So equal 2k. ln 6 equal 2k divided by 2. So get constant k. K is ln 6 over 2. In order to make accurate numbers, so you don't use calculate to calculate this now. You don't need to calculate this now. You just leave k with ln 6. Because if you use calculator, you got decimal number is only approximate number. And your final answer will not be accurate. That accurate is a little bit away. So leave with ln with ln for k is better. So then plug this k into this original function, and you got q of t equal q0 initial is 10,000 e to the power k. K is ln 6 over 2 times t. And that's the q of t. Now from here, ask you, how many bacteria will there be in the culture at the end of 4 hours? So T equal 4, plug in. T use 4, plug in. So over here, T use 4, plug in. Over 2, cancel, get 2 times ln 6. And this you can go ahead, power rule, get 6 squared. So it's 10,000 times e to the power ln 6 squared is 36. And the ln and the e are inverse function, cancel each other. So this is equal 36 times 10,000 is 36. Not, 36 times 36. Get 1, 2, 3, 4. 1, 2, 3, 4. Yeah, get this. So 360,000 bacteria after 4 hours. And what is the rate of growth of population after 4 hours? So you have to take derivative. So Q of t, take derivative. Q of t is this. Take derivative is 10,000. E, take derivative is still e. E to the power u. And this by the chain rule, this u take derivative. This take derivative is still times ln 6 over 2. And this part is original Q of t. So it's Q of t times ln 6 over 2. So figure out Q prime of 4, t equal 4. So that's equals Q of 4 times ln 6 over 2. Q of 4 we figure out over here is 360,000 times ln 6 over 2. So it's